When you're trying to rationalize a denominator with a cube root on the bottom, the process is a little bit different than it was with square roots. With a square root, when you multiply a square root by itself, you just end up with what was under the root. But with a cube root, that doesn't usually work that way. For example, suppose we're looking at the cube root of 1/2. Here we can go ahead and simplify the cube root of the top, which would be 1. In the denominator, though, we can't simplify that. We leave it as the cube root of 2. If we multiplied the top and bottom here by the cube root of 2, we would have the cube root of 4 on the bottom, but that's not something we can simplify. The goal is to end up with a cube root on the bottom that you can simplify. So to get rid of a cube root, we do need to multiply the top and the bottom by the same cube root. And the goal is to keep in mind we want to end up with, in the next step, a cube root in the denominator that's something that we can simplify. So let's think of those perfect cubes that we can simplify. 8, 27, 64, 125. That's 2 cubed, 3 cubed, 4 cubed, 5 cubed. Those are examples of numbers you want to try to turn something into. Here, we can turn 2 into 8 by multiplying it by 4. So if we multiply the top and the bottom here by the cube root of 4, we would end up with the cube root of 4 over the cube root of 8, and the cube root of 8 is 2. So the cube root of 4 over 2 would be our answer. Let's look at 2 over the cube root of 25. It helps to remember that 25 is the same thing as 5 squared. So we could think of this as 2 over the cube root of 5 squared. Now, if we had 5 to the third, the cube root of 5 to the third would just be 5. So here, to get it to be a cube root that we can simplify, we need to multiply it by one more 5 there on the bottom part. Then we'll end up on the bottom part, 5 squared times 5 to the third, 5 squared times 5, we end up with the cube root of 5 to the third. On the top, we would just have 2 times the cube root of 5. In the bottom, the cube root of 5 to the third is 5. So our final answer would be 2 cube root of 5 over 5. Let's look at 1 over the cube root of x. Here we have x to the first in our denominator. We would like to end up with an exponent that's a multiple of 3, because if we have the cube root of x to the third, or the cube root of x to the sixth, or the cube root of x to the ninth, those would all be things that we can simplify. So when we're trying to figure out what cube root to multiply by here to rationalize our denominator, we keep in mind that in the next step, we want something we can take the cube root of. We could take the cube root of x to the third. So to turn x to the first into x to the third, we multiply by the cube root of x squared on the top and the bottom part. Now on the bottom part, we'll have the cube root of x to the third, which is what we want. In the top part, 1 times the cube root of x squared, we have the cube root of x squared. And now to finish it, we simplify the bottom part. That's our whole reason for doing this. We don't have a root there anymore. We just have x. And in the numerator, we have the cube root of x squared. If you'd like to try the next 2 problems on your own, pause the video now and resume when you're ready to see the solutions. In the case of our first example here, 3 over the cube root of 9x, it helps to remember that 9 is 3 squared. So let's think of this as 3 over the cube root of 3 squared times x. Now here we've got a couple of different things under that cube root. So we're going to need to think carefully about both the number part and the variable part. Again, we need to remember our goal is in the next step to have a cube root that we can simplify. So for the number part, we have 3 squared. We would like to have 3 to the third, so we need to multiply by another 3. Then in the next step, we're going to have 3 to the third. For the x part, we have x to the first. To turn it into x to the third, we multiply by the cube root of x squared. Then in our next step, we're going to have something we like, the cube root of 3 to the third x to the third. So in our numerator, we have 3 times the cube root of 3x squared. We leave that in the numerator and simplify our denominator. The cube root of 3 to the third is 3. The cube root of x to the third is x. And now in this case, we do have one thing we can do to reduce it. Divide the top and bottom part by 3. And our final answer for this problem ends up as the cube root of 3x squared over x. If we look at our next problem, we start with 1 over the cube root of x squared. Here we would rather have the cube root of x to the third on the bottom part. We have x squared to begin with. To turn it into x to the third, we multiply the top and bottom by the cube root of x. And now we're going to have what we wanted on the bottom part, the cube root of x to the third. So here we would have the cube root of x on top. In the denominator, the cube root of x to the third is x.